And the last decision you have to make whenever you're adding disks into a Windows server has to do with how you want to configure the volumes. And now that we've converted this basic disk to a dynamic disk, we have a larger number of possible configurations that we can do for our volumes. Those are, if you can see here, a simple volume, a spanned volume, a striped, a mirrored, and then a RAID 5 volume. The first of these is the most basic of volumes that you can create, which is just a simple volume that does not have any of the additional features you might expect associated with dynamic disks. A simple volume can be configured for a certain amount of disk space, can be configured with a drive letter, and then it can be configured to be formatted in either the usual file system partitions, NTFS, exFAT, and now REFS or ReFS, which is Microsoft's newest operating system that supports additional redundancy and failure protection. Notwithstanding how I choose to format the volume, I can set an allocation unit size and a volume label here, and I can even choose to perform a quick format or turn on file and folder compression as part of creating that volume. Now, simple volumes are the ones that you see the most commonly here within the disk management solution. But in certain circumstances, you may find yourself wanting to use the Windows OS as the mechanism to consolidate multiple disks together to create a much larger or a more redundant volume. Let's come down here to this third item here, and let's bring this third disk online. And after we bring the disk online, let's initialize the third disk here with GPT so that I can show you all the different possible options that exist. The first of which here is a spanned volume. A spanned volume, all it does is provide a mechanism for you to take the contents of multiple different disks and literally attach them together, one next to the other, so that you will have more than one disk's worth of total storage available in the volume that you create. As you can see here, I've created two terabyte disks, or attached two of them together, to create a total volume size of essentially 2 terabytes, minus a little bit for the overhead space. But creating a span disk essentially allows you to connect those two volumes together so that you can use that total storage space in a single location with a single drive letter. Now, what's curious about when you're creating these span volumes is that you kind of automatically create the potential for a really bad day. Because anytime disks are connected together in a spanned volume, the loss of any of those disks will automatically cause the loss of the entire volume. So anytime you're doing this, make absolutely sure that you have either some sort of backups or some way to bring that disk back online should you lose it. For many of these reasons, you don't see a lot of spanned volumes in many organizations, just because for a lot of people, the potential of losing an entire volume with the loss of a single disk is a little bit overwhelming. Now you can solve some of that heartburn by creating, instead of a spanned volume, a mirrored volume. A mirrored volume takes two different disks and attaches them together, not necessarily to add additional disk space, but instead to create multiple copies of the data on disk. The mirrored volume creates two volumes. Here's disk 1 and here's disk 2. And when you add them together, you can see the volume size does not change. Still gives you a single drive letter, but two copies of the data are always available, one on one disk and one copy on the other disk. What this provides is that should you lose one of the disks, the other disk can continue to operate and can continue to service up clients without the loss of any data. Now, in certain circumstances, you may not care about the loss of data. You may instead care about the best performance possible across multiple different disks. You can actually enhance performance through what is called a striped volume. A striped volume takes data and stripes the data across multiple disks, 2 or even more disks. Doing so allows you faster access to your data than what you would get out of a simple volume or even a mirrored volume. Now, more disks here provides more different locations where data can exist. This provides more different spindles, the actual device that reads the data off of disk, so that those spindles can be working in parallel to gather whatever data you require. When you are interested in heavy performance or high performance and you don't care at all about high availability, well then a striped volume can provide that level of performance for you. The last of these options is a RAID 5 volume down here. And a RAID 5 volume requires at a minimum at least 3 disks for it to operate. You have to have the 3 disks because for every 2 bits of data, a third bit of parity needs to be calculated. That parity is not necessarily stored on the third disk, but is instead striped throughout all the disks as you're creating. And so this parity bit allows you to have the additional storage space, like what you would have with a spanned volume, but with the additional redundancy, like what you would have with a mirrored volume. And so as you can see here, when I'm connecting up these 3 disks, these 3 terabyte disks, I only end up getting 2 terabytes of disk space because the equivalent of 1 disk will be used for parity. RAID 5 can provide a little additional performance for reads, but at the cost of extra processing power for writes, because anytime you write data to disk, that parity bit has to be calculated.